Good afternoon. I'm Miss Wynn, and I'm going to give you some problems and help you guys work through them on thinking critically. Here we go. We'll start with problem number 1. All right, they give us the numbers 8, 10, 11, 12, and 13. We need to find the sums of these numbers across and vertically, and they have to equal 31. I started off with 8 in the middle. I put 10 and 13 on top and below, and then 11 and 12 on the sides, which 10 plus 8 plus 13 is equal to 31, and 11 plus 8 plus 12 is 31. Now, I've given a few different examples down here, and in order for this problem to work, 8 has to be in the middle. Now, you can mix up 11, 12, 10, and 13 in different orders, but they all have the same numbers, so I mean, this is just the only way you can work it. Now, B, they give us a box. Let me find one that's a little bit better. Okay, this one. All right, they give us a box with 4 bubbles in it, and there's numbers. We have 13 between these 2 bubbles, 11, 19, and 21. What they want us to do is to fill in these other bubbles, and in order to do that, we do, which this bubble and that bubble equals 13. So 13 minus 6 gives us 7. So we know 7 goes over here in this bubble. Now 11 minus 7 is 4, so we put it down here in this bubble. And 19 minus 4 is 15, so we put it here in this bubble. And 21 minus 15 gives us our starting bubble, which is 6. I've filled it in down here, and now you always want to double check your work. And in order to do that, since we found the answers by subtracting, we're going to add. So 6 plus 7 gives us 13. So 6 and 7 is 13. 7 and 4 gives us 11. 4 and 15 gives us 19. And 15 and 6 gives us 21. Now there's a few more problems just like that, and that's how you work those. Now problem number 2, they want us to make a solid pattern using 9 square tiles, and the tiles must touch each other. And they want us to calculate the perimeter after we sketch our figures. And the perimeter is all sides, which all sides of the little cubes are tiles. So I've sketched a few different figures, and I've calculated the perimeters. Like this one here, you just count each side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And that's how you get the perimeter. There's a few that have the same numbers, but we have 12, 16, 18, 14, and 20 as the perimeters. Part B of this one wants us to the least perimeter, which is the 12, and our greatest perimeter, which we had 2, and I just chose to do the stair pattern one. Problem 3 is they want us to find our path from one point to another. So problem 3A is you can only move upward or to the right, and they want us to find the possible paths from point A to point B. Now I solved this one using the Pascal's triangle, and here's it broke down here, which the bottom row, middle number is 20, so that's our answer. So there's 20 different paths from point A to point B. Now this one's a little bit trickier because there's lines with arrows on the end, and you have to follow the direction of the arrow. So I came up with 4 different paths from point C to point E, which we have C to B to E, then we have C to F to E, and then a couple little tricky ones. We can go from C to A, down to B, and over to E, and C to F, up to B, and over to E. On problem number 4, there's 4 parts of this one, I believe. Well, there's 3, sorry. 3 different ones, and I'll just go over, let's just do one of them. They want us to write an equation to solve each addition pyramid. We'll go with problem 4B. Now, here's our addition pyramid. The top number is a 15. We have 2 empty boxes. Then we have 1, the variable y, and 2. In order to solve this, we need to solve for y to fill in the rest of the boxes. So we have 1 plus 2 times y plus 2 equals 15, which is the top number. So we know 2 times y gives us 2y, and 1 plus 2 gives us 3, equal to 15. So we'll subtract 3 from 15, which gives us 12. So we have 2y equals 12. Divide 2 into 12, which gives us 6. So we know the variable y is 6. So 1 plus 6 will give us 7, and 6 plus 2 gives us 8, and 7 plus 8 gives us 15. That's pretty much how you work all of them. So we'll move on to the next problem because we don't have a whole lot of time. This one, we use a table to sort out who is married to whom. They give us David, Will, Floyd, and Gus, and their wives, Kitty, Sarah, Josie, and Ann. They give us a few clues on how to figure it out. I'll go over a couple of them just to show you guys how we're doing this. Okay, so Floyd is Josie's brother. So we know Josie and Floyd can't be married because they're siblings, so we'll just go ahead and mark him out. Josie and Gus dated some, but then Gus met his current wife. So we know Josie and Gus aren't married because he's married to somebody else, so we'll mark Gus out. So that leaves us with Will and David. Now the third clue they give us, it says Kitty is married to Will. So we give Will a heart under Kitty's name because that's her husband. We can go ahead and mark David, Floyd, and Gus out because she's married to Will. And then over here under Josie, she can't be married to Will because he's already married to Kitty. So we know she's married to David. On Sarah and Ann, we can go ahead and mark out David and Will on both of theirs because, of course, Josie and Kitty are married to them. That gives Sarah, Floyd, and Gus, and that gives Ann, Floyd, and Gus. So let's see who's married to who. So we know Ann has 2 brothers, and then Ann's husband is the only child. So let's go back over here to Ann. Her last 2 options is Floyd and Gus, which we know Floyd is Josie's brother, and if her husband's an only child, it cannot be Floyd. So we'll mark him out, and she must be married to Gus. And that leaves Sarah married to Floyd. Hopefully you guys caught all of that. All right, so and I wrote it down for you, so step by step of how to figure it out. Now, on problem 6 is the trapezoidal numbers. Kind of sounds a little scary, but it's not too bad. So the trapezoidal numbers it gives us is 1 plus 1 plus 1, 1 plus 2 plus 2 plus 2 plus 1, and 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1. The nth trapezoidal number is, we've got to figure it out. So they want us to create a dot pattern of the trapezoidal numbers they gave us and then figure out what the next one possibly could be. So 1 plus 1 plus 1 is represented with just 3 dots. The 1 plus 2 plus 2 plus 2 plus 1, we got 1, 2, 2, 2, and 1. Our next one, we have 1 dot, 2 dots, plus 3, plus 3, plus 3, plus 2, plus 1. Our final one, we have to keep with the trapezoidal shape that gives the name trapezoidal number. My drawing's not the best, but please bear with me. So we have a 1 plus 2 plus 3. Then our middle numbers are 4 plus 4 plus 4 plus 3 plus 2 plus 1. And if you can kind of see the shape of a trapezoid is present. All right, part B of this one, it says notice that 1 plus 1 plus 1 is 1 times 3, and 1 plus 2 plus 2 plus 2 plus 1 is 2 times 4, and so on. So they want us to rearrange it into rectangles. So here's 1 times 3, 3 dots. 2 times 4, you got 2 rows, or 4 rows of 2. 3 times 5 is 3 rows of 5s, and so on. Our final part, C, they want us to use inductive reasoning to show a formula that gives n the trapezoidal number. So we have n, open parentheses, or n times n plus 2, n plus 2 is in parentheses, sorry. And that would be our formula to figure out what the nth trapezoidal number is. I hope this has been beneficial in helping you solve problems thinking critically. This is Ms. Lynn. Have a good day.